So let's review what we learned last time. So last time we learned about the three laws of Newton. So the first law was the law of inertia, where an object at rest stays at rest, and an object in motion stays in motion. And the second law of Newton is the law of acceleration. It's basically states F equals ma, meaning that force is directly proportional to the mass and how it takes more acceleration or more force depending on how big the mass is. And you can also derive acceleration from this equation as well. So it is a very important formula. And there was the Newton's third law of motion, which is action and reaction. It states that for every action, there's an equal and opposite reaction. So if you apply a force, if you're pushing down to the ground, the third law states that the ground is also pushing up against you. We also learned about two important concepts of velocity and acceleration. We briefly talk about acceleration in this law, in the second law. Basically, you need to know what velocity is, which is the distance change over time. So it's distance over time is velocity, distance divided by time. But acceleration is the velocity change over time. So once you find the velocity, which is the distance over time, you can find the acceleration, which is velocity over time. If you actually put it out, it becomes distance over time squared. Becomes the acceleration. We also learned about force. We can derive the force from the law of acceleration, the Newton's second law. But basically what it is a push or pull that changes an object's motion or shape. And the unit is Newton. Examples are gravitational force, magnetic force, friction force, and force can be measured by a force meter, which measures the weight, or the weight is equivalent to gravitational force. And we also learned about work, which is force times distance. So work is basically um, how much force did over a distance, and the unit is in joules. And okay, so work happens when forces move an object. We also learned about potential energy. So here, potential energy equals mass times a gravitational constant times the height. And if the question asks you, what is the potential energy of a certain object? And if the mass and the height is given, since gravitational constant is always a constant, depending on where you are, if you're on Earth or if you're on Moon, um, you can plug in the gravitational constant and then plug in the mass and the height. If you multiply all of them, you will get the potential energy. Power is the rate at which work is done, and it tells us how fast energy is used. Because it's a rate, you divide work done over time. So it's work divided by time is power. Or that is also written as voltage times current is watt. That's just joules per second. That is the unit of power. It is how fast energy. Before I talked about the gravitational constant, gravitational acceleration, which is g. So on Earth, g equals 9.8. So you can plug this whenever mass, and you can calculate the energy, but you can also calculate the force since gravitation acceleration is also a part of the acceleration. From F equals ma, we can plug in the gravitational acceleration and becomes F equals mg. So if you look at the right, here's an example of how um, time and velocity changes. So since gravitational acceleration is 9.8, and then if you multiply by a certain amount of time passed, you can find the velocity at the moment. So you can see that the velocity is increasing. It's falling down faster and faster. And you can also find the force of an object by multiplying the mass by the acceleration, the gravitational acceleration. So far, it just maybe needs to know the concepts. And here is an actual question involving watt. So an electrical engineer was in your school to replace a 20-watt bulb with a 50-watt bulb. Use this information to answer the question below. So the unit inscribed on the bulb measures its so this question is asking you um watt is a unit of what? But watt, as we have discussed, was a unit of power. So it is work done over time, and that is power, and power is measured in watts. So it is also important to know the units. Energy is measured in joules. Work is also measured in joules sometimes, and watts is measured in joules per second, or that is also the power. Does this make sense to everyone so far? Is everything clear? Do you have any questions so far? Okay. So what 20 watts and 50 watts are telling us is that every second, 20 joules of energy is used. And for the 50-watt bulb, every second, 50 joules of energy work is done. So that is how you know how much energy or work done to a bulb from the unit of watts. So it is, this part is this second part of the same question. An electrical engineer was in your school to replace 20-watt bulb with a 50-watt bulb. And this question asks us to identify which statements are correct. Um, as the 50-watt bulb is likely to, does the 50-watt bulb increase the brightness in the room? Does it increase the amount of electricity consumed? Or does it destroy the habitat of pests? Do you guys know the answer to this question?
Think about it and then talk about it. Talk about the person. You think about the person before. Increase their brightness. Try habitat. How can
I think I heard someone say D, and that is correct. Um, it a 50-watt bulb, of course, increases the brightness in the room. Higher wattage means more energy consumption, and it results in a brighter bulb. You can see the comparison in this picture. The 25 watt, 40 watt, and 60-watt bulb. You can see that it's brighter. And 50-watt, um, like said in the previous slide, was how 50 joules of energy is consumed per second. And that is larger than 20 joules consumed per second. So it also increases the amount of electricity consumed. So it is 1 and 2. The next question. An electric bulb is rated 0.5 ampere on 120 voltage. Determine the power produced when the bulb is turned on. So this is another formula for power if voltage and the current is given. So I will explain this in the next slide, but I'm going to introduce you to the topic with a question. So here you can see power is also equal to voltage times the current. This is the second equation. Instead of um, the power which we thought of as work over time, it can also be measured in voltage times current. Since we have voltage of 120 and current of 0.5, if we multiply it, what do we get? We get the 60 watts. 120 divided by 2 is 60, and its measurement is in watt. So let's quickly look at this theory question. So it tells us to define the term light emitting diode, and this is actually the LED. So if a question asks you this, you can answer by saying, for example, LED is an electronic device that produces light when an electric current passes through it. So there is an electric current, and when there is certain, depending on how big the current is, it'll produce varying intensity of light. The difference between standard bulbs and an LED bulb is that LED bulbs are brighter, they use less energy, and they last longer. Versus a standard bulb, which produces light by heating a thin filament inside the bulb, LED bulb produces light when electric current passes through it. So the difference The basic difference is producing light or producing heat. Producing heat can also result in the light bulb sort of getting brighter. That is another concept. But producing heat can also produce light. But that is how the standard bulb does it. And for an LED bulb, directly produces light from the electric current. The second part asks us to mention two devices that use LED in their operation. So examples are LEDs are used in TVs, traffic lights, smartphones, and computer monitors. And that's they have because they need energy efficient. They need to be energy efficient and have a long lifespan. If it requires those, it is better to use an LED. Now we can look at this next topic, which is about Ohm's law. Let's. I'm going to introduce you to the topic with a question. So, the current is a resist in a resistor is 3, and if the resistance of the resistor is 4 ohms, determine the potential difference across the resistor. So here we can use the Ohm's law, which states that voltage equals current times resistance. So if you see a question that gives you the resistance and the current, or maybe if you're given a voltage and the resistance, or a voltage and a current, you can find the missing part by using the Ohm's law. Here, since the current and the resistance is given, you can multiply the two. So it's going to be 4 times 3, and it results in 12 volts. Here in Ohm's law, there are 3 very important concepts. The potential difference is also called the voltage, and the definition is the amount of electric energy transferred between 2 points in a circuit. So it is what pushes electric charges to move. A current is the flow of electric charge in a circuit. It is what flows, that's the current, and it is measured in ampere. And the resistance is the opposition to the flow of electric current. So it is what tries to, it can think of resist and resisting the flow of the electric current. It's trying to um, maybe slow it down or put the current to a stop. So on the right, here is a really good picture of all these parts in action. You can see the yellow, which is the volt, the potential difference, trying to push this green figure, stick figure, which is the current. So the current is trying to pass through, and the voltage is trying to help the current pass through. But here, resistance, measured in ohms, is trying to stop it, is trying to act as the opposition to the flow. It's blocking the flow of the current. But Ohm's law itself, voltage equals current times the resistance, says that the amount of electric current in a circuit depends on the voltage and the resistance. So more voltage means more current, since current is proportional to voltage. And more resistance means less current, because current is inversely proportional to resistance. What this means is that you see from here, the bottom right, you can see both V equals I times R. But if you divide the resistance on both sides, you get I equals V over R. This tells us that the current, which is I, is proportional to V. So more voltage equals more current. But if you also rearrange this equation, you can also set it up to be R equals V over I. This tells us that more current means less resistance, and more resistance is equal to less current because they are inversely proportional. It is when something equals 1 over something or a constant over something. That's when it is inversely proportional. So here was an example of Ohm's law bulb experiment. So here on the right, there is more current, and on the left, there are less current. So the more voltage, the more brighter it gets. So this is what the experiment is trying to prove. Since there are more voltage, there will be more um, electrons passing through. So it'll be more and faster electrons passing through, and it'll make the bulb brighter. It'll have more current. And this is the second part of Ohm's law, which is about the resistance. So on the left, since there are only small one resistant, it makes a brighter light compared to the one on the right, which has 4 resistors. So more resistors means less current, and less current means dimmer light. So does this concept of Ohm's law or everything else before make sense? Do you have any questions so far? Any questions about the equation, the law, or any words, any vocabularies? Um, is everything clear? Have any questions so far? If not, I can move on to some of the questions. So let's try this one. So the current flowing through a resistor of resistance, 10 ohms, is 2.5 ampere. What is the potential difference between the two terminals of the resistor? Can you guys solve this problem? Does anyone know the answer to this question? 33. So potential energy, if this helps, is potential difference is equal to the voltage, if this helps. So here, you can see 10 ohms. Ohms is a measure of resistance. So R is given to be 10, and the current is given to be 2.5, because ampere is a measure of current. It is asking us to find the potential difference, which is the voltage, and that equals the current times the resistance, which is 2.5 times 10. Then you will get 25, which is C. If this is making sense, we can try to solve this theory question. So it asks us to explain the term potential difference. And always know that potential difference equals the voltage. And what's the voltage? The voltage is the amount of electric energy transferred between 2 points in a circuit. If we look back at this diagram here, you can see that the voltage is the one pushing the electric charge to move. So you can explain the voltage as it pushes the electric charges to move. The second part asks us the potential difference across the terminals of a 100 ohm resistor is 250 voltage. Calculate the current flowing through the resistor. So if we rearrange this equation of V equals I times R, can find the current, which is I, by dividing R on both sides. So I equals V over R. Since voltage is 250, that is over 100 ohms, you will get 2.5 as the current. And the unit is ampere. Always write the A. So this is another important formula. So something you need to memorize is V equals I times R. V equals IR. And always have that in mind. Since the question can always ask you um, the current and the resistor and asks you to find the potential difference. Or if the voltage is given and a resistance is given, you can find the current. So always know, have this formula at the back of your head. I was trying to remember it. So here is an example of an ammeter, a voltmeter, and an ohmmeter. So all of them are basically used to measure each part. Voltmeter measures voltage, ammeter measures the electric current, and the ohmmeter measures resistance. This is what it looks like. What you can maybe tell is that ammeters and voltmeters all have these dials, and you can maybe tell from the dials, or if it says the amount of volt on the screen, you can determine it like that. Here are just some electronic circuit symbols. Um, you don't need to know all of them, but maybe it's important to know some of them and get you familiar with some of them. So ammeter, voltmeter, and motor are pretty simple. Ammeter is just A. You can think of A and immediately ammeter. Voltmeter is V. If you see V, immediately a voltmeter. And here, this represents the cell. You would see this quite a lot. Um, way more frequent than the other ones. So this is a cell. This represents the cell. And if there are two cells, then it is a battery. It's basically two of this one. And this is an example of a diode. This is an example of a capacitor. This is a fuse. If you see this, this is a lamp. It's where maybe the amount of electric current can be measured by how bright the lamp shines. This is also important. Kind of looks like a box, but this is the resistor. Remember we learned about what resistor does in Ohm's law, which sort of prevents or opposes the force of electric current. This is what resistor looks like. Um, at the down left, here's a transistor, which is not really important, but it's still good to know. And here finally is a switch. If a switch is open, it's not working. And if the switch is closed, um, it's basically functioning as an on-off switch. So it can be turned on and off from the switches. And here, if it asks you to draw the symbols for each, um, they can ask you this, but I don't think it is too important. Um, just know the basic shape. So resistor, like I said, is a box, just draw a box. And if it asks you to draw a diode, just remember it's like a triangle, but I wouldn't say this is as important as resistor or cell. Cell we've talked about is these two lines like this, and LEDs are shaped like this. The question might ask you to draw the symbols, and this is how you can do it. Just get yourself familiar with all these different shapes, since you might see them in a diagram. So is everything from this slide clear? Because I wanted to make sure before we move on. Do you have any questions about um, what symbol this is or what this is? If you have a question, you can ask me. If you don't have any questions, I'll move on to a question. So here is another question involving Ohm's law. So the way I know this is because it gives us, well, the current of a resistor in a resistor is 3 ampere, and the resistance of the resistor is 4 ohms. It asks us to determine the potential difference. We know potential difference is the voltage, and we can find from Ohm's law voltage V equals IR. I is 3, R is 4. So if you multiply them, we get 12 volt. Here I have a sample question. So, um, in your exam, maybe in a theory question, it might ask you this. So, here you can see from the diagram that voltage for A, voltage is 18 volts. The resistor, the resistance of a resistor is 6 ohms. And it asks us to calculate the current, which is I. Can you guys try this?
He's asking question.
I.
He said it's a sample question. If you find the current, if you find what the current, the I.
Can anyone tell me what I is for this? For A? B 18.
Yeah.
18. This is given. So what will be the I?
Make current the sample and put the values as
I heard 3. Yeah, that is correct. The I equals 3 here, and 3 ampere, since 18 divided by 6 is 3. And let's look at B. So let's try here. It asks us to find the voltage, and it's given the current and the resistance. So again, voltage equals I times R. Can anyone find the voltage for this B question?
actually for voltage. They didn't use the current and the resistance. So you put it in the formula and solve.
Maybe is the screen too small? I'm not sure if you're using a projector or a laptop, but um,
They are using a projector.
oh, okay.
Uh-huh.
Here is just equals
They,
1.
they got that. They got that.
So the voltage will be 30 since it is
Yeah.
1 ampere times 13 ohms is V equals IR. And let's look at the third question, C.
Okay, I'm coming.
It asks us to calculate R.
How is it? I just got two.
Yes, that is right. I think it's
It's
almost
two.
right. That is correct.
Is that correct?
Yes, two is correct,
It's
and the right,
two. Okay, I
yes,
need yogurt.
two ohms. Yeah, that's correct. And you can solve it from this equation. If you say 8 voltage and 4 ampere, you divide 8 by 4, which is 2, and you are
Okay,
correct.
but when I get to that question, it's been you. You're doing me. Yeah. My classmate.
Great job, everyone.
My
Let's look
classmate are
at
doing
this next um, topic, which
it.
is the resistance in series and parallel circuit. So what this is the placement of resistors. And depending on the placement of the resistor, it can either increase the total resistance or decrease the total resistance. For series circuits, which is aligned side by side, you can see from the picture, it's aligned side by side. It's all in the same line. Then it is a series circuit. And the total resistance can be calculated by adding each part, adding the resistance of each part. For example, if you have three 10 ohms resistors in a series, the total resistance would be 10 plus 10 plus 10, which is 30 ohms. Series resistance can also be in a parallel circuit. And the R total is calculated by 1 over the total resistance equals 1 over the first resistance and 1 over the second resistance and the 1 over the third resistance. So if you have three 10 ohms resistors in parallel, the same 3 ohms resistor, but it is in parallel, then it would be 1 over R total equals 1 over 10 plus 1 over 10 plus 1 over 10, which equals 3 over 10. But 3 over 10 is equal to 1 over our total. If you have this, then our total be equal to 10 over 3. You can see here that 1 over our total is 3 over 10. So if you flip it, you have to flip the second one too. R total equals 10 over 3, which is also 3.3 ohms.
This I don't understand.
Oh, okay. Yeah, I'm glad that you understand. And you can tell from our total that the parallel circuit lowers the total resistance. This is the important part. The parallel circuit lowers the total resistance while the series circuit increases the R total. So if you have three resistance in parallel, the total resistance is going to be less compared to um three resistance in a series. Now let's look at this theory question. So it is about parallel series resistors, and it tells us to first calculate the effective resistance in the circuit. So it is asking us to find R total, the total resistance. Can you tell from the figure on the right, is this parallel or series? Can anyone tell me?
It's para.
That's right. I heard the person in front say that it's parallel, and that is correct. They are in
Okay,
parallel
my dear.
because you can see from here that parallel resistors are across the box, while series is next to each other. This is across, so it is parallel. And how do we
Okay.
calculate our total of parallel resistors? It is 1 over our total equals 1 over the first resistance, which is 4. So it's 1 over 4 plus 1 over 5. And the second one is 5 ohms. And if you add them together,
Okay.
yeah, it becomes 9 over 20. But RT, since it's 1 over RT, you have to flip it. And it becomes RT equals 20 over 9 ohms. That is the total resistance in the circuit. The second question asks us the current that will flow through the circuit when it is closed. So we can use the total resistance to find the current. Let's look at this diagram over here. On the right, you can tell that the voltage is up here, 6 voltage. See here. And we just found R to be 20 over 9. So we can use Ohm's law, which is V equals I times R. And I equals V over R by rearranging. And you can solve I equals 6 divided by 20 over 9, which just also equals multiplying flip one. This equals 54 over 20. And that would be in ohms. If you divide that, you don't need to do that in maybe the exam, but you can leave it as 54 over 20. It'll be ohms. Oh, sorry. Since this one is in current, this is actually in ampere. So it's A. So this is actually not correct. This is supposed to be ampere. Since the unit of a current is in A, ampere. So did this make sense for everyone? You have any question?
Please. Yeah, no. Yeah.
No questions?
Please, you
Then,
can move on.
okay, sounds, yeah, thank you for telling me. Um, Yeah, let's look at this next theory question. So first,
Okay.
identify each of the components labeled 1, 2, and 3. So 1 is here. Um, do you know
Cell.
what the symbol is?
Cell. The one is cell.
Yes, that is right. This is cell. And what is
And the
2?
I switch.
Yes, 2 is a switch. And this is a little difficult. What is
Current. The three is current.
the
No
3 is
current.
current passes,
Four.
and it is, yeah, a bulb. It is a lamp or a bulb. Yeah, those are
Okay. Yeah.
okay. And the second
Um.
question, state the type of arrangement of resistor in B. So is this series or parallel in B?
It's
Yes, I think
parallel.
parallel, that is right. What about for A? Is this parallel or series for A?
That's a series.
Yes, that
But
is
it's a
right.
series there.
I heard series. That's correct.
I'll put on.
Okay, let's look at this third part. To state the effect of the arrangement of resistors in each of the diagrams A and B on 3. So 3 is the bulb, and remember that brighter the bulb means more electric current. And in A,
Okay.
yeah, the arrangement of resistors in series can reduce the brightness of the bulb. But in B, adding more resistors in parallel makes the bulb brighter compared to a single resistor or a series arrangement.
Okay.
Um, and the reason for each is that the resistors in series have an increased resistance, and the resistors in parallel have decreased resistance. Yeah,
Okay.
yeah, okay. If this makes sense, I think we can move on.
Yeah. Okay. Let's move on.
Okay, so which of the following instruments is connected in parallel across a resistor in an electric current? So here is the resistor.
It's B.
And what is parallel? What is this? Right here.
B.
Yes, that is correct. That is the voltmeter. And what?
Yes. Both.
Yes, that is correct. And here you can see the voltmeter is across, it's parallel, and the ammeter is actually in series since it is next to R2. It's in series with the resistor.
Okay.
Okay, let's move on to this next question. So first, name the measuring instrument that is parallel or series with the resistor. Again, here, this is parallel, and this is in series. So you can see uh, resistor is across the voltmeter. So voltmeter is always parallel to the resistor. And you can see the ammeter, A, is always in series with the resistor. It's in next to each other. Voltage is across, which is parallel. Yeah. And the second question, what quantity does each of the named instruments in one measure? Well, the voltmeter measures the voltage, and the ammeter measures. Do you guys know what ammeter measures?
No, please.
It measures the electric current. So voltmeter is for voltage, ammeter is for electric current. And three, read the recorded values as indicated on A in ampere and V in volts. You can tell from this picture that this is three. It's like a clock. You can think of it as a clock. Three, four, five.
Yeah,
Yeah,
5,
so A
6.
equals 5 ampere. This is pointing at 5. And here, voltage is 8, 7, 7, 8, 9, 10.
7, 10.
It's pointing at 10, so it's 10 voltage. And it's 5 ampere. That's one way you can tell the amount. And here,
Okay.
it asks us to use the values greater than 3 to calculate the value of R. Can you guys do this question? Yeah, I'll give you a hint. This is close.
Yeah, beginning last one. Okay, so 10 equal to 5 R 5 3 2.
Oh, yes, that is correct. It is 2. R equals 2. Yeah, great job. And
Yeah, yeah, yeah.
yes,
2
sir.
ohms.
2 ohms. Yes, that is correct. Always include the unit 2 ohms. Its current is in ampere, volt is in volt, resistance is in ohms.
So that's the ohm. That's it.
And number
Okay,
5, one precaution to be taken in performing this experiment. Uh, this is not really important. You can say that ensure voltmeters and ammeters are connected correctly, check for loose connections, but this is not really important, in my opinion. But but one important one I think is to avoid wet hands and surfaces. This is pretty important because the electric current can move through ions in water and it can shock you, so be careful when you have wet hands. Uh, last time we cut off when we said just to avoid wet hands when performing this experiment because water in your hands has ions and electric currents can pass through waters. And You just need to be careful. But
Okay.
move on to this capacitor question. So a capacitor is connected in a series circuit with LED, a battery, and a switch. When the circuit is closed, the LED, so um, you need to know what capacitor is. So capacitor is an electronic component that stores and releases electrical energy and releases, and it takes, and it's like a temporary battery that discharges quickly. I think um I thought the computer was cut out. The, this will be the last topic before we end. So yeah, here capacitor.
Please, you guys are making noise. Say, I can't. Yeah, solving some question. I can't see it too. My face is.
Can you see the screen? Okay. I hope I can continue now, if that's okay. Yeah, there we go. I think it's
Yeah.
back to normal. Yeah. So, like I was saying, a capacitor is an electronic component that stores, releases electrical energy. It's like a battery, but it discharges really quickly. So when it is discharges really quickly, it flashes and goes off. So here, let's look at what capacitors really are. So capacitor is an electronic component, again, that stores and releases energy really quick. An example is like a camera flash. When you have a flash on a camera, it stores energy and releases it really quickly. So here, there's a difference between a battery and a capacitor. Battery also stores and releases electrical energy, but the difference is that the capacity storage is less. The battery stores way more energy, but the capacitor releases the charge at a very fast rate. But the battery, relative to the capacitor, releases more slowly. The capacitor symbol basically looks like this. This is a battery, and this is a capacitor. That's what it might look like. So let's look at this theory question. So figure 1C is an electric circuit diagram and answer the question that follows. So 1, state one function where each of the parts labeled 1, 2, 3, and 4. So does so what is 1 over here? Does anyone know? This is the battery. That's right. It's a cell. And it converts chemical energy to electrical energy. Number 2 is a switch, and it closes and opens circuits. And 3 over here, we just learned is a capacitor. It stores and releases electric energy really quickly. 4, always remember this box is a resistor. So the second question is that if the voltmeter reads 2.4 volts and the ammeter reads 0.8 ampere, calculate the value of the part labeled 4. So 4 is the resistance, and it is telling us to find the resistance when the voltage is 2.4 and ampere is 0.8. So it's 2.4 divided by 0.8, which is 3 ohms. And third question, state one way of conserving the value of the part labeled 1 in the circuit. One way you can do it is by opening the switch when not taking the readings. It's a way to conserve energy in a battery. Number 4, state 2 observations that can be made when the circuit is closed. You can say that when a circuit is closed, current flows and the needle on the ammeter moves to indicate the value of current. And the voltmeter meter also moves to show the voltage across the component. So two observation is that ammeter changes and the voltmeter changes when the circuit is closed. So I think we're going to end here. Um, do you have any questions so far?
Then, hello, Jevin.
Yes. Do you have questions so far?
So today's lesson was very good.
I actually, oh, quickly before we leave, I think it's better to, um, look at transistors quickly too. So before we end, I would like to maybe talk about transistor real quick. So yeah,
Okay, okay, okay. Let's
so
finish it.
yeah, okay, if it sounds good, then it's okay. So the diagram here is a
Okay,
transistor, and the arrow basically shows, um, the electron movement. So transistor is a
okay,
little, um, so you just need to know what it is, basics of it. So here, the current is flowing in the direction of the arrow. And here is what it looks like, um, as an actual object and as a symbol. This is a transistor. And
okay,
what it does is that a transistor is a device that controls an electric current by acting as an amplifier or switch. So, as an amplifier, the transistor can increase electrical output. It can also function as a switch. So, the transistor can alternate between on and off phases. And these abilities have made transistors important for everyday applications. So it ranges from computers to space satellites. So transistor is very important. It can amplify current or turn off or turn on the current.
okay,
And this is just, the parts of a transistor. This is not really important. Just know what it is. So there is E part, B part, and a C part. So E part is the emitter. It sends or emits electrons into the transistor. The base is the middle and very thin part. It controls the flow of electrons from an emitter to the collector. And the collector collects the electrons from the emitter. So
But please, is that all? Kevin?
are you finished writing it down?
Yes, please.
Okay. So so you can kind of see from this perfect example. So the base is the middle. You can think of it as a fossil. The base is the middle. It controls the flow. It can turn the knob to make the current faster. Emitter is where it sends out electrons into the transistor. Collector is the part that collects the electrons from the emitter.
Okay.
And these are just types of transistors. This is not really important, but they might ask you this in a question.
Why is it
So,
not important?
um, because it might be a little difficult, as a concept, but they might still ask you. There might be one or two questions on the exam about this, but I think the other parts were more important than this concept. But just know that there are PNP and NPN transistors. There are these two different types of transistors.
Okay.
So PNP transistor, current flows from the emitter to the collector when the base is activated. So you can see the electric current flowing from the emitter to the collector. You can see the arrow. So PNP from emitter to collector, you can write it like that. And
Okay.
NPN is from collector to emitter.
Please, I'm done. Continue.
Okay. So let's try this question. Which of the
Okay.
following statements about the base of a transistor are correct? So is it one, made very thin, two, made very wide, three, responsible for activating the transistor, or four, made of N-type semiconductor? So base, it is very thin. So one is correct, one is good. It's not wide, so we can cross out two, right? Middle and very thin. Controls the flow of electrons from emitter to the collector.
Is it
So yes, actually that is right. So
okay.
it is A. It is very thin and it's not very wide. And yes, it is responsible for activating the transistor,
Okay.
but it is not really made out of N-type semiconductors. So it is A. So this is the last question. This is really the last question of the day. And the
Okay, okay.
base, yeah, the base of the NPN transistor normally, so A is a p-type semiconductor, is an n-type semiconductor, is undoped semiconductor, or have electrons as majority charge current carriers.
B is B.
If you actually look at it here, this is the NPN structure. It's actually A. So NPN, this is why it's called NPN. It has connections. But you can see the P is the base. You can see from the picture. P is the base, and the base serves as the semiconductor. So what is the base here? It's P, so it's P-type semiconductor. You can always think of the base as being the semiconductor, whatever is in the middle. If it was um, P and P, then it would be an N-type. But since this is NPN, the base is P, so it is a P-type semiconductor. Yeah, this concept
Okay,
is
okay.
can be a little difficult, but I hope it still made sense to everyone.
Yes, yes, please.
So just know the important fact that transistors can serve as an amplifier or a switch. So that is the function
Okay,
of a transistor, they ask you. Do you have any questions for today?
okay,
Do you have any questions for today to ask me, or
Kevin, please, today's lesson is good, so we don't have any question.
okay, but,
Yeah, I understand everything.
okay, just in case transistor might not be as clear, um, is you can think of PNP as looking like this because P and P for NPN, here's the collector is N, base P, emitter N. So it just shows the order. So always something in the middle is the base. So whenever they ask you a question about what is here, what is the type of semiconductor? If it is PNP, it is an N type because N is in the middle. It's the base. But if it is NPN, P is in the middle and it is a P type semiconductor. Yeah, that is all I have to say. And if you don't have any questions, I will see you guys next week.
Okay, okay.
All
Thanks
right.
for the lesson today.
Okay, yeah, you're welcome. And
Okay,
see
okay.
everyone next week. Bye.
Please,
Yeah.
please attend my greeting to your parents. And
Can you repeat that?
Kevin, I said extend my greetings to your parents.
Oh, yeah, okay, I will do that too.
Oh,
All right, yeah. Bye everyone.
okay. Bye, bye.
Bye.
Ah. Yeah, bye, bye.